Good day, everyone. For today's lesson, we're going to tackle exponential functions, differentiation, and integration. I am Jovielyn Kathley A. Manalo, your discussant for today. For our learning objectives, at the end of the lesson, the student should be able to develop properties of natural exponential function, differentiate natural exponential functions, and integrate natural exponential functions. Let us define first what is natural exponential function. The inverse function of the natural logarithmic function f of x is equal to ln of x is called the natural exponential function and is denoted by f inverse of x is equal to e raised to x. That is, y is equal to e raised to x if and only if x is equal to ln of y. The inverse relationship between the natural logarithmic function and the natural exponential function can be summarized as shown. Ln of e raised to x is equal to x and e raised to ln of x is equal to x. Okay, let's try example number 1. Solving an exponential equation. So our given here is 6 is equal to e raised to x plus 1. So again, you can convert from exponential form to logarithmic form by taking the natural logarithm of each side of the equation. So first step, write original equation. So that is 6 is equal to e raised to x plus 1. And then take the natural logarithm of each side. So the result is ln of 6 is equal to ln of e raised to x plus 1. And now we can apply the inverse property. So that will result to ln of 6 is equal to x plus 1. And we can now solve for the value of x. So x is equal to negative 1 plus ln of 6. And using your scientific calculator, you can get the approximate value of x. So that is 0.791. And you can also check your solution if it is correct by just substituting the value of x. So from original equation, that is 6 is equal to e raised to x plus 1, just substitute negative 1 plus ln of 6. So if you get the same value at the end, so therefore your solution is correct. Let's proceed to example number 2, solving a logarithmic equation. So our given here is ln of x minus 3 is equal to 5. To convert from logarithmic form to exponential form, you can exponentiate each side of the logarithmic equation. So first step, we're going to write the original equation. So that is ln of x minus 3 is equal to 5. And then exponentiate each side. So that will result to e raised to ln of x minus 3 is equal to e raised to 5. And we can now apply the inverse property. So that will result to x minus 3 is equal to e raised to 5. And we can now solve for the value of x. So that is e raised to 5 plus 3. And using our scientific calculator, we can get the approximate value of x. So the result is 151.413. You can use a graphing utility to check a solution of an equation. So one way to do this is to graph the left and right hand sides of the equation and use the intersect features. So for instance, to check the solution to example number 2, enter y sub 1 is equal to ln of x minus 3 and y sub 2 is equal to 5. The solution of the original equation is the x value of each point of intersection. So the solution of the original equation is x is equal to or the approximate value of x is 151.413. As you can see in the graph, that is our point of intersection. The familiar rules for operating with rational exponents can be extended to the natural exponential functions. In order to understand more regarding these rules, now we will discuss operation with exponential functions. Let a and b be any real numbers. Number 1, e raised to a times e raised to b is equal to e raised to a plus b. And for number 2, e raised to a over e raised to b is equal to e raised to a minus b. So to prove the property, you can write ln of e raised to a times e raised to b is equal to ln of e raised to a plus ln of e raised to b. So that will result as a plus b. And you can rewrite as ln of e raised to a plus b. And for number 2, that is ln of e raised to a over e raised to b is equal to ln of e raised to a minus ln of e raised to b. And the result is a minus b. And you can rewrite that one as ln of e raised to a minus b. Next, let's discuss the properties of the natural exponential function. Number 1, the domain of f of x is equal to e raised to x is from negative infinity up to positive infinity. And then the range is from 0 to positive infinity. Number 2, the function f of x is equal to e raised to x is continuous, increasing, and one-to-one on its entire domain. And then number 3, the graph of f of x is equal to e raised to x is concave upward on its entire domain. And then number 4, the limit as x approaches negative infinity of the function e raised to x is equal to 0. And then last one, number 5, the limit as x approaches positive infinity of the function e raised to x is equal to positive infinity. So here is the graph of natural exponential function. The natural exponential is increasing and its graph is concave upward, as you can see. Next, let's discuss derivatives of the natural exponential function. Let u be a differentiable function of x. Number 1, derivative of e raised to x is equal to e raised to x. And then number 2, derivative of e raised to u is equal to e raised to u du. To prove property 1, use the fact that ln of e raised to x is equal to x by definition of exponential function and differentiate each side of the equation with respect to x. So the result is 1 over e raised to x times derivative of e raised to x is equal to 1. Then after that, multiply each side by e raised to x. So the result is derivative of e raised to x is equal to x. And then for property number 2, the derivative of eu follows from the chain rule. Let's try to solve example number 3. So in letter A, the given is derivative of e raised to 3x minus 1. So for this case, we are going to use property number 2. So that is derivative of e raised to u is equal to e raised to u times du over dx. So we're going to apply chain rule. So first, we let u as 3x minus 1. And then the derivative of 3x minus 1 is equal to 3. And then replace u and then du over dx so that the result is e raised to 3x minus 1 times 3. And our final answer is 3e raised to 3x minus 1. And in letter B, the given is derivative of e raised to negative 2 over x. So same property, property number 2. So we let u is equal to negative 2 over x. Or we can rewrite this one as negative 2x raised to negative 1. So we can easily get the derivative of that one. So that is 2 over x squared. So just substitute u and then du over dx. So our final answer is 2 over e raised to 2 over x times x squared. Our final answer is 2 over x squared e raised to 2 over x. Next, let's try to solve letter C. So that is derivative of x raised to 3 times e raised to x. So for this case, we're going to use product rule. So that is derivative of u times v is equal to u times derivative of v plus v times derivative of u. So that is x raised to 3 times derivative of ex. So that is still e raised to x plus e raised to x times derivative of x cubed. So that is 3x raised to 2. And then simplify. So our final answer here is equal to 3x raised to 2 times e raised to x plus x raised to 3 times e raised to x. Next, letter D. So the given here is derivative of e raised to 2x over e raised to x plus 1. So for this case, we're going to use quotient rule. So that is derivative of u over v is equal to v times derivative of u minus u times derivative of v over v raised to 2. So copy e raised to x plus 1 and then the derivative of e raised to 2x is 2e raised to 2x minus e raised to 2x times derivative of e raised to x plus 1. So that is e raised to x over e raised to x plus 1 squared. And then simplify. So our final answer here is e raised to 3x plus 2e raised to 2x over e raised to x plus 1 squared. Next, integrals of exponential functions. Here are the integration rules for exponential functions. Let u be a differentiable function of x. Number 1, integral of e raised to x dx is equal to e raised to x plus c. And then for number 2, integral of e raised to u du is equal to e raised to u plus c. So let's try to solve example number 4. That is integral of e raised to 2x plus 1 dx. So in this case, we're going to use rule number 2. That is integral of e raised to u du is equal to e raised to u plus c. So first, we let u is equal to 2x plus 1. And then du over dx is equal to 2. So we will convert the whole integral in terms of u. So we need to solve for dx. So our dx here is du over 2. Now, let's convert it to u. So the result is integral of e raised to u du over 2. This 2 means 1/2, so we can pull all the way outside. So the result is 1 over 2 integral of e raised to u du. And let's go back to rule number 2, that integral of e raised to u du is equal to e raised to u plus c. So our final answer is e raised to 2x plus 1. We will substitute the value of u over 2 plus c. Next, let's try example number 5. Integral of 3x times e raised to negative x squared dx. So we let u is equal to negative x squared, and then du over dx is equal to negative 2x. Then convert the whole integral in terms of u. So first, we need to regroup the integrand. So the result is integral of 3e raised to negative x squared times x dx. And then we need to solve for x dx. X dx is equal to negative du over 2. So now we can write the integral in terms of u. So that is integral of 3e raised to u times negative du over 2. So we can pull outside the constant, that is negative 3 over 2. And then the integral of e raised to u du is equal to e raised to u plus c. So our final answer here is negative 3 over 2 e raised to x raised to 2 plus c. Another example, integral of e raised to 2 over x squared dx. So we let u is equal to 2 over x, and we can rewrite this one as 2x raised to negative 1. So we can easily identify the du over dx. So du over dx is equal to negative 2 over x squared. And then our dx is equal to x squared du over negative x squared du over 2. So we can rewrite also the given integral from integral of e raised to 2 over x squared dx to integral of e raised to 2 over x times 1 over x squared dx. So we convert this in terms of u. So that is e raised to u times 1 over x squared times negative x squared over 2 du. So we can cancel out x squared, 1, and then we can pull out negative 1/2. So the result is negative 1/2 integral of e raised to u du. And integral of e raised to u du is e raised to u plus c. So our final answer here is negative e raised to 2 over x over 2 plus c. Okay, for our last example, the given here is integral of cosine x times e raised to sine x dx. So we're going to use property number 2. We let u is equal to sine x and our du is equal to cosine x dx. So we're going to convert our integral in terms of u. So that will result to integral of e raised to u du. And if we're going to go back property number 2, the integral of e raised to u du is equal to e raised to u plus c. And after that, we substitute the value of u. So our final answer is e raised to sine x plus c. And that is the end of our discussion. Thank you for listening.